Mixed transformations of quadratic functions. So this is where we combine all the transformations together. So we have a couple things going on. So let's review what each one of these parameters does to our function. So first we have the plus or the minus. This only has one job. Basically, if it's a positive, that means there was no reflection over x-axis. If there was a negative here, so -2, -1/2, -8, doesn't matter, that means it was reflected over the x-axis. That's the plus or minus in the front. Then we have a. Doesn't matter if a is positive or negative, a just controls the width of our function. So the first thing we have is if the absolute value of a is greater than 1. That means there was a vertical stretch. By a. If the absolute value of a is less than 1, that means there was a vertical compression by a. So vertically stretching it will make it narrower. Vertically compressing makes it wider. Then we have the x minus c. So this is what shifts it left or right. The inside parentheses will always go backwards from what the sign should do. So the first option we have is x minus a number. That creates a shift right c units. Minus should go left, but because he's inside parentheses, that means it's going to be backwards. It actually goes right. And then we have x plus a number. That will shift left by c units. Again, positive should go to the right, but because it's inside, it's backwards. And then the last transformation we have is plus d at the end. This is the one that actually does what it's supposed to do. So if you have plus a number on the outside, that means you will shift up by d units. If you have minus a number, that means you will shift down by d units. Okay, so now let's combine all of these transformations together into these equations and describe what happens to these functions. So these are all in function notation. So this says that we are starting with the quadratic parent function x squared, but because these are function notation, these could be any function, but we're just specifically doing it for quadratics right now. So we're going to take g of x equals 2f of x minus 3 plus 5. So we have to decide what each one of these parameters are for. I just like to start in the front. So in the front are your a values. So since 2 is greater than 1, that means the first transformation is a vertical stretch by 2. That's one transformation that happened. Then we have this x minus 3 on the inside. That's our c parameter. And this is the one that works backwards. So since it's x minus 3, what that means is you're actually shifting right 3 units. And then we have plus 5 in the back. That's the d parameter. So the plus 5 means we are shifting up 5 units. So this had 3 different transformations to it. So the transformations were vertically stretched by 2, shifting right by 3, and shifting up by 5. Example 2. G of x equals -5/2 f of x plus 1. So again, find your parameters. So this -5/2 is our a. But there's really 2 transformations here. So the negative is what makes it reflect over the x-axis. Then the 5/2, that's what controls the width. Well, 5/2 is greater than 1. So that means there was a vertical stretch by 5 over 2. That's all in the a value. So there's two things all wrapped up into one. Then we have x plus 1 on the inside. That's our c parameter. So since it's x plus 1, that really means that this will be shifted left 1 unit. So there's 3 transformations on this one too, even though there's only 2 parameters. The a really does multiple things. G of x equals 1/5 f of x minus 6. So we have an a, 1/5. Since 1/5 is less than 1, that means there was a vertical compression by 1/5. And then we have minus 6 here at the end. That's our d parameter. So minus 6 at the end means you will shift down 6 units. 2 transformations here. Now, where I'm getting all these from is this what we just wrote at the very, very beginning. So this may be something that will be very useful to write down and even possibly memorize, because all the functions that we do transformations for, this will never change, ever. G of x equals negative f of x minus 2. Okay, well, negative in the front. Now, there's a 1 here that nobody writes. So the only a we have to worry about is the fact that it's negative, because if you look at your layout, there's nowhere here on a that says equal to 1. Because if you multiply something by 1, you're not actually changing it, which doesn't create a transformation. But the fact that it's negative does. So the negative in the front means it will reflect over the x-axis. And then we have x minus 2 on the inside. That's our c parameter. The x minus 2, this is the one that's backwards, will shift right 2 units. So 2 transformations here as well. Now, these are not in function notation. If you notice, these don't have the f. This actually has the x squared that tells us we're using the quadratic function. But the process stays the same. A is in the front, so this is your a. Since 3 is greater than 1, that means this is vertically stretched by 3. And x minus 4 is inside my square, so that means this has to be my c. And this is the one that's backwards, so this will shift to the right 4 units. 2 transformations here as well. G of x, negative 3 over 4 x squared minus 5. So we have a number in the front. This is our a. Now again, it's negative and there's a number, so there's 2 things that are happening. So the negative tells us to reflect over the x-axis. The 3 over 4 part, that is less than 1, this tells us that it will be vertically compressed by 3 over 4. Now let's look at some graphs. So for each of the examples, describe the transformation that took place from the quadratic parent function f of x to create the function g of x. So again, here's our parent function. So a couple things we want to remember. The parent function always has a vertex at 0, 0. The ratio from one point to the next point should be 1 and 1. So that means up or down, and then right or left 1 to get to the next. So if you're not 1 and 1, that means there was either a stretch or compression. If you're 1 and then less than 1, so maybe here it was stretched. If you're past the over 1, that means it's wider, so that means there's a vertical compression. And the next thing is you got to remember that the original function opens up. If it does not open upward, that means there was a reflection that occurred to it. Let's try some examples. So number 1, what are the transformations that took the parent function to this graph? So I like to start at my vertex. So my vertex should be here at 0, 0. Well, now it's at 0, negative 4. So that means it was shifted 1, 2, 3, 4, 5. Sorry, 0, negative 5. It was shifted 5 units down. Now I'm going to look for any A value changes. So that means stretch or compress, and then possibly reflection. So reflections are easy to see. Since this graph still opens upward, that means there was not a reflection, so that didn't happen. Now let's check our 1-to-1. So it should be up 1 and right 1, but if you notice, I get to my graph before I hit the first tick mark. So that means that this new graph is actually narrower than my original. So since it's narrower, that means that there was a vertical stretch. And those are the only two transformations that occurred to get this graph. Number 2, start with your vertex, see if there's any shifts, any translations. So it should be at 0, 0, and now it's here. So that means I had to move right 2 and up 1 to get to my new vertex. So there was a shift right 2 and up 1. Now let's look for a reflection. So it should be facing upwards like this, but this one's actually facing down. So that means that yes, there was a reflection over the x-axis. And then last, see if there's maybe a stretch or compression. It looks like it's wider, but we have to make sure because our scales on our graphs are not always the same. So the stretch or compress, start at your vertex, try to find your next point. It should be 1 and 1, but I still have to keep going to hit my graph. So that means this new function is actually wider than the original. So that means there was a vertical compression. So there's actually 3 transformations here. Example 3. Start with your vertex, see if there's any shifts or any translations. Should be at 0, 0. Now it's way over here. So I had to move left 1, 2, 3, 4. So I went left 4 units and 1, 2, 3, 4 down. See if there was a reflection. So in this case, this graph is facing upward, and so does our parent function. So there was not a reflection done to this function. Last, make sure there's no stretch or compress. So I should be up 1 and right 1, but I hit my function before I get to my first tick mark. So that means that this graph is actually narrower, which means there was a vertical stretch. And last one. So example 4. Find your vertex, 0, 0. Well, the vertex didn't move, so there was no shifts left and right. It did, however, it should be facing upwards like this, but now it's facing down. So there was a reflection over the x-axis. Then we have to make sure there was not a stretch or compress. So find your 1. So here's a 1 and over 1. And I actually hit my graph at 1 and 1, which is what it's supposed to do according to my parent function. So there was not a stretch or a compression. This is the same width as the original function. So you actually only have one transformation here. It was just reflected over the x-axis.